Hey guys, so today I just wanted to show you guys some practical applications of scale factors and enlargement and reduction, or scaling up and scaling down. This will be followed up by a worksheet which you guys have to um, work on. And to recap from the previous lecture on scale factor, so the scale factor tells you how many times bigger than the normal an object is in reality. We saw this last week where a given any two measurements, you will be able to calculate whichever one is missing, either the new measurement or the old or the scale factor itself. So working back and forth with this, you can be able to calculate scale factors. And we also covered some scale drawing, introduction on scale drawing, and mentioned that scale factor, which is more than one, it means that the shape gets bigger, and that is called enlargement or scaling up. Then if the scale factor is less than one, it means that the shape gets smaller, and that is called reduction or scaling down. So if we can use a two-dimensional shape, for instance, it can be enlarged or scaled up by some given value. When you do that, we will say this is a scale factor. How this looks is as follows. If you have that two-dimensional shape and it has measurements, length and width, and then you have to enlarge it by some given amount to get to the new image. I'm hoping you're noticing this based on the from the previous formula that I said you can work back and forth with. You work with the old measurement and the new measurement. Over here you have the old object and the new object. So you can still apply, in fact, you still apply that formula. So then the new image will have the length and width that is twice the previous one. This means the scale factor is 2 because uh, the length of the size of the object is twice as big as the original one. So the enlargement will be a scale factor of 2. And then if the scale factor was 3, as you can imagine, this length and width will be 3 times the original object, and the scale factor will be 3. So another way to work out the scale factors and enlarge or reduce images in your drawings would be um, using the center of enlargement, having one point that is called center of enlargement. If you're using the center of enlargement to locate where the enlarged or reduced image is going to be, follow the coordinates. For instance, you have this object and then you have that point as your chosen center of enlargement, and you can choose any point. It can be here, it can be there, it can be here, it can be there. So what you do with the center of enlargement, you will draw lines from that point going through the vertices of the shape, which is the outermost or the corners of the shape. From that to there, to there, to there, to there, going past there. Those lines are called construction lines, or the technical term is ray lines. So our center of enlargement over there, you draw your first ray line or construction line through this point here all the way, and you continue to do so going past the vertices, which is the outermost parts of any shape or the peak of any shape. In this case, to simplify it, you could just say through the corners of this rectangular shape. After you draw all your ray lines, the next thing you do is, what is the distance from my center of enlargement to the first corner, and then what is the distance from there to there, and distance from there to there. Let's look at the first one, distance from there to there, and the way you do it would be to say, to get from here to there, it's either 1 square down and 2 squares across, or 2 squares across and 1 square down. But you have to be consistent if you start by counting this way or that way with the other points. So since it's saying using a scale factor of 2, what you do next is, this scale factor, using this method, you have to count from center of enlargement by doubling that. So that means 4 squares that way and 2 squares this way from the center of enlargement. So there it says in what's there, 4 squares right, 2 squares down. So 4 squares that way and then 2 squares that way. That will be your first point. Then you do the same for the other points and say, to get from there to there, how many squares across and how many squares down? 5 and a 1, and then the scale factor is 2, then it becomes 10 squares to the right and 2 squares, literally doubling what you did in the first phase. You said 5 and a 1, double that, that's 10 and a 2. You get your next point. Similarly, you go to this one, what is the distance from the center of enlargement to the corner, and then using a scale factor of 2, that means you will do, it will be 2 squares to the right and 3 squares down, using a scale factor of 2 that multiplies to 4 and a 6. Hopefully you are following this, and you have your 3 points there. You can already see where the shape is going to go. You don't even need to do the last point, this one, which you can from there and draw your line that passes through here and extend it all the way, and then you can count your squares to the right and down and multiply that by whatever scale factor that you are told. But because it's not even necessary, as you can already see, you have enough points to draw the image, you just draw it there. But just for your practice, try and do that last point. Then if we use a scale factor of 3, we follow the same process. There is an object that you have to scale up from the center of enlargement, or enlarge from the center of enlargement. That is your first construction line or ray line, and then you do the same. Then the scale factor is 3 this time. So that means you will say, with the scale factor of 3, this point here, from the center of enlargement, it is 2 squares to the right and 1 square down. Multiply what you just did by 3. So that means that part multiply by 3, this part multiply by 3, or literally from there, do what you did the first time 3 times. So scale factor of 3, that would be 6 and a 3, and you put a point there, and then you do the exact same thing that we did with the previous scale factor of 2 until you have enough coordinates Hopefully you guys are following this, and already now you see where your enlarged image or scaled up image is going to be with the 3 coordinates, and then you just draw it. Again, you can do the 4th ray line just to make sure you understand and you are confident with this. At the center of enlargement um, determines where your enlarged or scaled up image is going to be. If you look at this, when the center of enlargement is there, that's where you will get your new image. Then if you move your center of enlargement lower, it pushes the new image up, and it keeps doing that. You can test this out by drawing the construction lines from the center of enlargement of these images just to test it out, but it should be straightforward. So that's all it does. Moving the center of enlargement away from the object moves the image further away in the opposite direction, and then moving it up and down as well, and then moving the center of enlargement up moves the image down, and vice versa. Yet another way to work out the scaling up and scaling down of objects, if you don't do the counting of squares, or if you don't do the actual maths calculation, the numbers using the formula and setting up proportions, you can use this method as well. So for this one, the scale factor is 3 from the center of enlargement. So using a similar approach of drawing construction lines or ray lines from the center of enlargement through the vertices of any object, those will be your vector line, this one to that one to that one, and you need for this one and that one there. So having drawn your construction lines, what you can do is literally measure the distance from the center of enlargement to the first point where it contacts your object. Be a first one, that's a second one, and that's a third one. You count from the center of enlargement as you did with the previous method of counting squares. You count from the center of enlargement. So even with measuring, you measure the distance 3 times from the center of enlargement. That means the scale factor of 3. That's the first point where of your enlarged image. Then you do the same thing for the rest of your ray lines and vertices. You measure the distance from the center of enlargement to the first point, and then follow what the scale factor is by measuring 3 times now. That distance, that's 1, 2, and 3. That's your next point. And then you do the same thing for that one. The distance from there to there, you measure that, that's 1, that's 2, that's 3. You measure along the line, the ray lines. Then again, this one, the distance from there to there, 3 times from the center of enlargement puts your next point there. Finally, distance from there to there, 3 times, because scale factor is 3, puts your next point there. And then all you do is connect your coordinates, and that's your enlarged or scaled up image. This will be your original image, and this will be the new one. And with the scaling down, you can still use the same approach, but it will mean going from the large image to a smaller image, and then you would still apply the construction lines or vector lines as well. There are many ways questions can be asked. We've just enlarged now using the center of enlargement, and you were figuring out where the new image is, the enlarged image. The question can be in a reverse to say where is the old image if this is your new image. Or it could be this one here where they give you two images and they say figure out where the center of enlargement is here. So you will still draw your construction lines from points to points. So this point corresponding to that one, this one corresponding to that one, this one to that one. So you just draw construction lines through, and where they meet, that will be your center of enlargement. Then here's another example. So again, you still need to find the center of enlargement. You do the same thing, corresponding points, draw your construction lines all the way through, and then where they meet, that would be your center of enlargement. That brings us to the end of this practical way of working out scaling up and scaling down. So I think at this point you are ready to tackle these things in a worksheet. So yeah, cheers guys.